You felt it this morning. That sudden jolt when a car horn blared outside your window. Your chest tightened. Your breath caught. Your eyes shot wide open before your mind had even processed what happened. And then, a second later, you realized it was nothing. Just a car. Just noise. Just another ordinary moment in your ordinary day. But here is what nobody tells you. Your body was not overreacting. It was doing exactly what it was designed to do. And that design is millions of years old. Your brain still thinks you are being hunted, not metaphorically, not as a figure of speech. At the level of raw biological architecture, the part of your brain responsible for that heart-pounding, breath-stealing, eye-widening response does not know you are safe. It does not know you live in an apartment. It does not know predators have been largely removed from your daily life. It runs the same ancient program it has always run, and it runs it fast. Here is how old this goes. Before there were humans, before there were even primates, small mammal-like creatures were scurrying through the underbrush of a world dominated by things that wanted to eat them. Their survival depended entirely on one thing: speed of response. Not accuracy, not careful analysis, speed. The creature that paused to verify the threat was already dead. The creature that moved first, questioned later, lived to pass its genes forward. Neuroscientist Joseph Ledoux spent decades mapping this system. He called it the low road. When your senses detect something that might be a threat, a small almond-shaped cluster of neurons deep in your brain, called the amygdala, fires before your conscious mind receives any information at all. It bypasses your rational cortex entirely. It hijacks your body in under 200 milliseconds. Your heart rate spikes. Cortisol and adrenaline flood your bloodstream. Your pupils dilate. Your muscles prime for movement. All of that happens before you can even think the word danger. Ledoux showed this in animals. Rats that had their auditory cortex entirely removed, rats that could no longer consciously process sound, still flinched in fear when they heard tones previously paired with a shock. The signal never reached the thinking brain. It never had to. The amygdala intercepted it and responded on its own. Your brain works the same way. Think about the last time you were startled by something that turned out to be harmless. A shadow in your peripheral vision, a loud sound in the middle of the night, the buzz of your phone in complete silence. Your reaction came before your thought. That is not a flaw. That is the system performing exactly as it was built to perform. But here is where it gets strange. The amygdala does not just respond to real threats. It responds to anything that resembles a threat pattern it has learned to recognize, and its threshold for resembles is extraordinarily low. It would rather fire 1,000 false alarms than miss one real predator. Psychologists call this the smoke detector principle. A smoke alarm set too sensitive will go off every time you make toast. That is annoying. But a smoke alarm set too conservatively might not go off during an actual fire. From your brain's perspective, 1,000 false alarms are an acceptable price for not being eaten once. This is why you flinch at a stick that looks like a snake before you see it is a stick. This is why a masked figure in a horror movie makes your pulse race even though you know you are sitting in a theater. This is why hearing your name spoken in a crowded room will pull your attention before you consciously register that anyone has said anything. Your threat detection system is not calibrated for modern accuracy. It is calibrated for ancient survival. Researcher Arne Öhman at the Karolinska Institute in Sweden ran a series of experiments that revealed something extraordinary. He showed people photographs very briefly, so briefly they could not consciously identify what they had seen. Among the photos were images of snakes and spiders. Participants showed measurable fear responses, measurable physiological reactions to snake and spider images even when they could not consciously say what image they had seen. The fear arrived before the awareness, and snakes, specifically, appear to hold a privileged place in this system. Primatologist Lynn Isbell proposed the snake detection theory. She argued that snakes were among the most persistent and deadly predators of early primates, and that the primate visual system, including the enlarged and precise visual cortex of humans, may have evolved in part specifically to detect snakes. To spot the coiled pattern, the slow movement, the particular texture hidden in undergrowth. Look at what this means. Your ability to see clearly, to track fine visual details, The sophisticated visual processing system that lets you read these words right now may have been partly shaped by a predator that has not threatened you personally in your entire life. Evolution does not update quickly. It cannot. A trait that helped your ancestors survive gets passed forward. It persists even when the original pressure disappears. Your amygdala is running threat detection software that was written millions of years ago. It has not been patched. It does not receive updates. It simply keeps running. And this creates a very specific kind of mismatch between the world you actually live in and the world your brain believes you live in. Stress researcher Robert Sapolsky has written extensively about this gap. He points out that zebras do not develop ulcers. A zebra feels the threat of a lion, floods its body with stress hormones, runs for its life, and when the threat passes, the zebra goes back to grazing. The system activates and then turns off cleanly. Human beings, Sapolsky argues, are the only animals that can activate that same stress response with thought alone, with worry, with anticipation, with replaying a conversation that happened 3 days ago or imagining a meeting that has not happened yet. Your brain cannot reliably tell the difference between a real threat in your environment and a vivid imagined threat inside your own head. The amygdala responds to both. The body floods with cortisol either way. The muscles prime. The heart accelerates. The lion is not there. But your body prepares for it anyway. This is why modern anxiety is not simply a chemical imbalance or a weakness or a product of living in difficult times. It is an ancient system encountering a world it was never designed for. A system built for discrete, physical, short-duration threats now asked to process abstract, social, ongoing concerns. Deadlines, debt, reputation, relationships. These are not lions. But your brain treats them with similar urgency because it does not have another category for thing that could end you. And it is not only fear. The same system that watches for threats also trains itself based on experience. The amygdala learns. It flags patterns that previously predicted danger and wires them deeply. This is why a smell can transport you instantly back to a frightening moment from childhood. Why a tone of voice that resembles someone who once hurt you can make your body tense before your conscious mind identifies why. Why some fears feel completely irrational even to the person who holds them. The rational brain knows the threat is not real. The amygdala does not care what the rational brain knows. Ledoux described it this way. The connections running from the emotional brain to the rational brain are stronger than the connections running the other direction. Your feelings influence your thinking more than your thinking influences your feelings. That is not a poetic observation. That is an anatomical fact. There are more neural pathways going from the amygdala up to the cortex than from the cortex back down. You are, at the level of your brain's wiring, built to feel first and think second. What do you do with this? Some researchers, including psychologist Lisa Feldman Barrett, have pushed back on the idea that fear responses are simply hardwired and unchangeable. Barrett argues that emotions, including fear, are constructed. They are the brain's best prediction based on past experience and context, not automatic reflexes beyond your influence. This means the stories you tell yourself, the context you bring to a sensation, genuinely shape how your threat system responds over time. Naming the feeling, locating it in the body, recognizing it as ancient machinery doing its job rather than an accurate signal of present danger, these things do not switch the system off, but they engage the cortex. They bring the thinking brain online, and they can slow the cascade. Not eliminate it, slow it. Because here is what the science makes clear. You are not broken when your heart pounds before a presentation. You are not weak when a social conflict triggers something that feels animal and desperate in your chest. You are not irrational when a shadow in a parking garage makes every muscle in your body coil tight. You are old, ancient, actually, carrying millions of years of survival engineering in a skull that rides the subway and answers emails and tries to sleep through notification sounds at 2 in the morning. That jolt you felt this morning, that car horn that sent adrenaline surging through your body before your eyes were fully open, your ancestors would have called that staying alive. You just call it Tuesday.